We now analyze the function f of x equals x squared over x squared plus 192 and sketch its graph. So first we are going to determine the intercept. So let's determine the x-intercept. We determine x-intercept by replacing f of x equal to 0 and solving for x. So therefore this equals 0 equals x squared divided by x squared plus 192, and when we multiply both sides by this expression we get x squared equals 0, and this gives x equal to 0. So the x-intercept is 0, that is 0 comma 0 is the x-intercept. Now let's determine y-intercept, and we get y-intercept by plugging x equal to 0. We already determined that when x equal to 0, uh, y is also 0. So we can say that y equals 0 when x is also 0. That is 0 comma 0 is the y-intercept. So we write both x-intercept and y-intercept as the origin point 0 comma 0. We now determine the relative minimum and relative maximum of this function. So for that, we have to first determine the critical point of the function and determine the sign chart of the critical point of the function, as well as the first derivative using that critical point of the function. So let's determine the critical point of the function, which we get by setting up this equal to 0, that is f prime of x equal to 0. So let's find the derivative of f of x. We find the derivative of f of x, which is f prime of x, by using the quotient rule of derivative to find the derivative of the right side expression. So I write the denominator expression, which is x squared plus 192 multiplied with the derivative of x squared, which is 2x, minus, now I write the numerator polynomial x squared, then multiply with the derivative of x squared plus 192, which is 2x, and this has to be divided by x squared plus 192, the square of the denominator polynomial. Now let's simplify this and set this up equal to 0 and then solve for x. So first let's simplify this, and this equals, we distribute this 2x with the terms x squared and 192. So 2x times x squared is 2x cubed plus 192 times 2x is, we multiply the 192 with the 2, which is 384x, minus 2x times x squared is 2x cubed, and this is over x squared plus 192 quantity squared. Now let's set this up equal to 0, that is the first derivative equals 0, and so I'm replacing this by 0. We multiply both sides by this denominator expression, so we remove the fraction on the right side. We can also see that this 2x cube, negative 2x cube gets cancelled, leaving us only with this expression 384x divided by x squared plus 192 quantity squared. And when you multiply both sides with this expression, we get 384x equals 0. And this means x equal to 0 is the critical point of the function. Now, using this critical point of the function, we can determine the sign chart of the first derivative. That is, we create a number line and mark this x equal to 0. We are preparing the sign chart for f prime of x. We take some random values to the left of x as well as to the right of x. I'm going to take negative 1 and plug it into f prime of x. So let me copy the f prime of x, which is 384x. This is over x squared plus 192 quantity square. And so if you plug in x equal to negative 1, the numerator will be negative, that is negative 384. And this is always going to be a positive quantity, irrespective of what we plug in, because we have this quantity square. So whatever the number inside the brackets, whether it is positive or negative, is always going to be positive. So here we have a negative quantity divided by positive, which is a negative quantity. So we mark to the left of x equal to 0, f prime of x, that is the first derivative of f of x is negative. And now let's plug in some random value to the right of x. We plug in x equal to 1. And so when we plug in x equal to 1, we will get 384 times 1 divided by the denominator is always positive. And so this is greater than 0. So we mark the right side of f prime of x is positive. And so therefore we can see that to the left of the critical point x equal to 0, we have the first derivative negative, which means it is a decreasing function. So we can draw the graph as something like this. It's decreasing till it reaches x equal to 0, where the first derivative becomes 0. That is, it has a horizontal tangent, and afterwards it increases. So we draw it like this, and so we get the shape of the f of x around x equal to 0 as like this. And this means this at x equal to 0 is a point of minimum. That is, we see that it is a relative minimum at x equal to 0. And so we can determine its coordinate by plugging x equal to 0 into the original function. And when we do that, we get f of 0 equals 0 squared divided by 0 squared plus 192. And so this gives 0 divided by 192, which is 0. So therefore, we can see that the coordinate of relative minimum is x comma y, which is 0 comma 0. So therefore, we write relative minimum of the function is 0 comma 0. And we don't have a relative maximum, as we were able to see that we got only one critical point, that is x equal to 0. So there is no relative maximum. You see that it is none. We now determine the points of inflection of the graph of f of x. For that, we have to find the second derivative and set this up equal to 0 and determine the points of inflection. So let's find the second derivative f of x. For that, I'm going to find the derivative of f prime of x, which gives the second derivative of f of x, that is f double prime of x, and this equals, we can use the quotient rule of differentiation once again to find the derivative of f prime of x. So first, I write the denominator expression, that is x squared plus 192 quantity squared, and then multiply this with the derivative of the numerator polynomial. Here it is 384x. The derivative of 384x is 384 minus, now I write this numerator polynomial multiply with the derivative of the denominator expression, that is x squared plus 192 squared. We find its derivative. So when we first apply the power rule, we put this power, which is 2, in front, and then multiplied with the expression x squared plus 192 raised to the power of 2 minus 1, which is 1. So we can just write down x squared plus 192, and then multiply with the derivative of the inside expression using the chain rule. So the derivative of x squared plus 192 is 2x. And so basically this simplifies to 2 times 2x is 4x times x squared plus 192, which I write down here, that is 4x times x squared plus 192, and this is all over the square of the denominator expression, that is x squared plus 192. We already have a square, so when you square it up, we will get raised to the power of 4. Now let's simplify this and set this up equal to 0. So we have f double prime of x, and this equals, we see that we have this factor x squared plus 192 in both terms, the first as well as the second term. So we will factor that x squared plus 192. Also, we see that this number is also can be factored. So we factor 384 also. And when we do that, Here we will be left with only 1 power of x squared plus 192 minus in the second term, if we factor 384 as plus x squared plus 192, we'll be left with x times 4x, which is 4x squared, and this is over x squared plus 192 raised to the power of 4. And now we can simplify this. We have x squared negative 4x squared, which is negative 3x squared. So I'm going to change this to 192 minus 3x squared. This is negative 3x squared. And now we set the second derivative equals 0 and determine x. That is f double prime of x equals 0, and we should solve for x. And so when we do that, uh, we have this expression, that is x squared plus 192 times 384 multiplied with 192 minus 3x squared. This is over x squared plus 192 power 4 equals 0. We multiply both sides by the denominator expression to remove the fraction, and when we do that, this will get removed from the left side expression, and we will see only this product equals 0. And now we can consider that either this term equals 0 or this term is 0 according to the zero property of polynomials. So this cannot be 0, that is x squared plus 192, or otherwise is 384 times x squared plus 192. This does not have any solution because this x squared is always going to be positive, and this inside expression is going to be a positive number rather than 0 for any values of x. So it does not have solution. So therefore we consider another part, that is 192 minus 3x squared, and this equals 0. We can add 3x squared to both sides and solve for x from this one. 3x squared equals 192. So dividing by 3, we get x squared equals 64. And so this one, if we take the square root, we get x equals plus or minus 8. So therefore, we see that x equal to plus or minus 8 could be the points of inflection. We have to determine whether they are potential points of inflection. So we will now put them on the number line and create a sign chart for this points. So I'm going to create a number line. I mark negative 8 here, and this is positive 8 here. This is for the sign chart for second derivative. So let's copy the second derivative, that is f double prime of x, and this equals, we will utilize this expression. In fact, we can simplify this one, we can reduce this to third power. So I'm going to write down 384 times of 192 minus 3x squared, and this is over x squared plus 192 quantity cube. So this is the simplified form of the second derivative function. Now let's consider some random values to the left as well as to the right of this point negative 8. Let's say if we consider x equal to negative 10, which is to the left of x equal to negative 8, we plug it into the second derivative. That is, it will become 384 times 192 minus 3 times of negative 10 square is 100, and this is over x squared plus 192. So we have to replace x by negative 100, and this will become positive 100 over cube. You see that this 192 minus 300 is negative here. This one is a positive number, and this one 100 plus 92, 192 is also positive. So we have product of positive, negative, and positive, which is negative. So therefore, we can mark to the left of negative 8, it is negative. And now let's take some random values to the right of negative 8. So I'm going to take negative 6, and we will plug that into the second derivative. And so when we do that, we get f double prime of x. Plugging negative 6, we get 192 minus 3 times of negative 6 square is 36. This is over, once again, this is positive 36 plus 192 cube. So this is positive, this is also positive. We have to check this. 3 times 36 is less than 192. That is, it is 192 minus 108. So this is also positive. So this is positive, positive, and also the denominator is positive. So everywhere we get positive is going to be a positive number. So to the right of negative 8, we see that it is positive. And this means that to the left of x equal to 8, it is positive. Now let's determine to the right of x equal to 8 by plugging 10. If you plug in 10 into the second derivative, we will get 384 times 192 minus 3 times 100 divided by x squared is 100 plus 192 quantity cube. And so once again, this is going to be negative number. This is positive. This is 192 minus 300 is negative, and this is positive. So we have product of positive negative, which is negative divided by positive is negative. So we mark negative to the right of x equal to 8. Just going to clear this. And now we can see that at x equal to negative 8 and x equal to 8, we see that it's a point of inflection, because whenever the second derivative is negative, we say that it is concave down. So it's going to look like this, concave down. Can draw it like this. Okay, here I've drawn the graph of concave up and concave down when the second derivative is negative and when the second derivative is positive. Here it is concave up, here it is concave down, and here it is concave down. So you can clearly see that at x equal to negative 8, there is the concavity changes, and also at x equal to 8, the concavity changes from up to down. So whenever the concavity changes, we see that these points are points of inflection. So we consider x equal to negative 8 and x equal to 8 as points of inflection. We can find the corresponding y values by plugging into f of x. So let's do that. So we plug x equal to negative 8. F of x is x squared divided by x squared plus 192. And we plug this, we get negative 8 square is 64 divided by 64 plus 192. And so this equals 64 divided by 64 plus 192 is 256. And this equals 1/4 or 0.25 in terms of decimal. So one of the coordinate of the points of inflection is negative 8 comma 1/4, or in terms of decimals it is negative 8 comma 0.25. And similarly, when you plug in x equal to 8 into this, we get the same value, because this is going to be positive and this is going to be positive 64. So we are going to get the same y value. So we say that 8 comma 1/4 is also points of inflection, or 8 comma in terms of decimals it is 0.25, This is also the points of inflection. We will now determine the asymptotes of the graph of f of x. So first we will determine if there are any vertical asymptotes. For this, we have to set the denominator equals 0. So here we have the denominator x squared plus 192. If we set this up equal to 0, this does not have solution because x squared is always positive. A positive number with positive number will never become 0. So therefore no solution. And so it means no vertical asymptotes. Now let's determine the horizontal asymptotes. For that, we compare the degree of the numerator and the denominator expression. They both become equals. That is, degree of numerator is 2 and degree of denominator is also 2. So whenever we get this type of rational functions where the degree of numerator and degree of denominator equals 0, we simply take the coefficients, divide like that. So the coefficient of x squared in the numerator is 1 and the coefficient of denominator, that is the x squared in the denominator, is also 1. So therefore this becomes 1 by 1 equals 1. And so we can say that y equals to 1 is the horizontal asymptote. And since we determine horizontal asymptotes, we can say that it does not have slant or oblique asymptotes. So no slant or oblique asymptotes. Okay, now that we have analyzed the graph of the function f of x, we can draw the graph of f of x. So here I have drawn the graph of f of x. I have drawn this horizontal asymptote y equals 1, and I have also drawn the graph such that it is having a relative minimum at the origin 0 comma 0. Also the x and y intercept is 0 comma 0, and so we have a horizontal asymptote y equal to 1. This means we draw the graph as like it is touching this line y equal to 1 and x equal to positive or negative infinity. And so here there is a change of concavity at x equal to negative 8 as well as at x equal to positive 8. It changes from concave down to concave up at x equal to negative 8, and at x equal to positive 8 it changes from concave up to concave down. So using all this information we draw the sketch the graph of the f of x as like this, and we can verify this by plugging this function into the graphing utility. And so when we do that, we get exactly the, sorry about it, similar graph as we can see from this graph which we obtained through the graphing utility.